Hi, I'm Manuel Rode, one of four brothers running Rode. As a family company, we've been building kilns for over 40 years, focused on helping potters get the best results. That's why we're bringing Rode kilns to the US. Visit us at rodekilns.com or follow Rode USA on Instagram. Rode, enjoy your results. And now, enjoy the episode.
This episode is sponsored by Monkey Stuff. Monkey Stuff makes things for makers. We're inspired every day by the craft and creativity of makers and design and manufacture tools and accessories to try to make your making life a bit more delightful. Our products are designed in California, by makers and for makers, and manufactured in the USA. Check out our line of pottery accessories and tools at monkeystuff.com. Follow us on Instagram to see what we're up to in our studios, and keep on making great things.
Hey, this is Erin with Cornell Studio Supply, located in the gem city of Dayton, Ohio. As a proud sponsor of this episode, we are happy to help you with all your pottery and ceramic sculpture needs. Join us this summer for a glaze mixing workshop with our very own low-fire expert, Ben Carter, July 24th through the 26th. Visit cornellstudiosupply.com to sign up. At Cornell Studio Supply, we are owned and operated for potters by potters.
Hello, my name is Kathy King, and welcome to the For Flux Sake podcast. I'm coming to you from the Harvard Ceramics program in our fair city, Allston, Massachusetts. I'm here with Rose and Matt Katz of the world-famous Ceramic Materials Workshop, and they are ready to answer your burning questions about clay and glaze. Well, hello, Matt and Rose.
Hey, Kathy.
Hey, Kathy.
We're going to open up with something I thought was kind of hilarious to hear. But what I heard was that we had discussed your new endeavor, which is so very exciting, which is called Wear Glazes. And we had talked about it on April 1st. So people think it was an April Fool's joke.
Yeah.
I mean, to your credit, it does sound too good to be true that I can just pick I could take a producer Ben's shirt color. I could send that to you and you can make a glaze for me.
Mm-hmm.
That matches that.
Yeah. I mean, it would be a pretty good joke if they went to Ensika and then did the airing. I mean, that would be an awesome, really well-planned joke, but it's not a joke.
It sounds too good to be true. And it is something that we've worked on for decades. And when somebody said that, I couldn't believe it. And that it happened. And we even missed it because we had a family medical thing we had to deal with on April 1st. So we weren't really paying attention to the podcast when it was coming out. And, but somebody had said, oh, this is a funny joke. And I was like, it's literally not a joke. This is what I've strapped myself to software development for now, like over a year, trying to make this thing happening, working with a team of insane software engineers who we call our brain trust, who have helped us to build this thing. And it comes out on April 1st and everyone thinks it's a joke, but no, this is not too good to be true. This is very real. And it is launching this summer. Actually, this episode is pretty close to our launch date. And go to wearglazes.com and literally design the glaze that you want, the color that you want exactly, the temperature. We've talked on previous episodes about how temperature needs to be specific. The temperature you want exactly. Rock solid, robust glazes, exactly how you want them, custom made for you from the ground up. It's not a joke.
Any color that ceramics can make. It's pretty amazing.
And then you're going to mix it and then you're going to mail it to me. Yep. You're going to be mailing powders to all our homes.
Uh-huh.
We have checked at this. And yes, you guys
you've double checked this.
We're spreading our white powder problem to everybody in the community.
Mm-hmm. It's a white. You're going to get a package of white powder in the mail.
Well, not with all these colors available. It's never going to be white. right?
It is true. All the colors of the rainbow and then a few more. But actually, the shipping is important because we are manufacturing the glazes. Some people have asked about, hey, can you send me the recipe? That's what ceramicmaterialsworkshop.com is for. Come and learn how to make all the recipes. But this is for the people that don't want to make their own glazes, who want to have it made for them.
Who can't make their own glazes.
Yeah.
Don't have the studio, don't have the facilities, but want it custom. And we're doing some other things that are really important, like sending them. We are sending dry vacuum sealed powders. So they can't pop, but they also are shipped in an envelope. So there's less packaging, less waste. And all you have to do is just add water. Like we've got mixing instructions and all of that. And it just makes it so much cheaper because you're not paying to ship water. You're not paying for a fancy bottle. It makes it so much cheaper. And then on top of it, because it's all custom, it's all dynamic pricing. So literally you'll watch the prices change as you change your design because it's calculating, I need this much of this material and that much of that material. And it's honestly, it's much cheaper than the commercial glazes are out there, and it's yours.
Well, I've been fortunate enough, because I'm in the know, to be involved in some early beta testing. And one question I had for you two is, holy guacamole, every color like that I was picking and playing around with has some like cuckoo coconuts name to it. Who had the job to sit and think of 5 trillion color names?
all I've got going for me in my life is puns. So
they're so fun. I mean, yeah, okay, that makes a lot of sense. Okay.
I mean, I could just call it blue number 872.
Oh no.
No. Oh no.
No. They're just to see the names of some of the colors is worth going on and checking this out. I mean,
and you can give them your own names, but if you don't, I've got a list of names that it'll assign them. So
yeah, you got Matt's punny names like Teal of Time and Mermaid Money and
oh god,
funny stuff.
Mermaid Money. I want to know about what acid trip that came from, but
it was peyote, Kathy. Thank you.
Okay, all right, yeah, on natural. Okay. Oh my goodness. All right. Well, we should switch over to some of these fabulous questions that we have queued up today. Our first question comes from Subha, who asks about thermocouples.
Hi, my name is Suba Aaron Javia. I live just outside of Philadelphia. I am a hobby potter. I like to say I'm new. I started a couple years ago. I basically try to find every moment that I can to play with mud when I'm not doctoring or parenting. But I have a question I'm worried might cause some eye rolls, but it's about thermocouples. I have listened to your couple episodes with Freddie and multiple other episodes about kilns. I have just purchased my first kiln, so the order is already in, although I'm only a week into having ordered it. And of course, I did not order the upgraded S thermocouples because everyone told me I didn't need to. And then of course, I listened to all your kiln episodes. And I guess my question is, I only ever fired a cone 6. I don't fire higher than that. I do like precision. I am a scientist and I do like things to be accurate, but I don't anticipate ever firing hotter than cone 6. And I'm just wondering how big of a deal this is that I bought a kiln that has type K couplers. Should I try to call the manufacturer, ask them if they can change it? Acknowledging that I really didn't budget for another $1,500 since there are 3 thermocouples in this kiln. Is it possible to even change your thermocouples after the fact later when these ultimately degrade? Just hoping to get some additional guidance there. Thanks so much for everything.
Well, Suba, I mean, I think, unfortunately, you're just going to have to throw that kiln out. So just put it in the trash and just put a label on it that says Kathy King, care of Harvard Ceramic Studio.
Oh, nice.
And just
Okay.
put a whole
I'll
book of
take it.
stamps on it.
Yeah, because we're too cheap to get all the S thermocouples. That's great. Bring it on.
Yeah, you're fine. Ish. I mean, Kathy, you just said it. You guys use K-type, right? You survive
We do.
K-type.
Well, I mean, we just I budget a certain amount and we're trying to switch them all over, but I can't do all, 12 of them
all at once.
at one time. Yep.
Yeah. I cannot argue they're crazy expensive, as Rose never stops telling me when I buy more thermocouples.
Uh-huh. Yeah. Well, I mean, good thing you don't have to buy many.
we have not bought any in years because
your last one you broke was a little while ago.
The cool kids are listening, Rose. I didn't break it. It was the cat. Knocked it over.
Accidents happen. Things break. It's not a big deal.
They happen to me a lot. Is having a K-type thermocouple the worst thing in the world? Now, first of all, you do need cooler friends, because the fact that they all told you don't need it, your friends aren't cool enough. So I'm just saying.
Listen, our local repair person tried to talk me out of it, telling me that this was not needed.
That's that's what I don't get. He's talking himself out of business. So there's a problem.
I know, right? Yeah.
But why would you tell anyone that you? Well, I just did some other business math on your kiln person.
Oh, what?
Okay, I don't know your kiln person. I do my own kiln maintenance. We're not going to name.
Which is not extensive.
We have a couple of people that we work with. So
actually, I could tell you exactly why they told you not to upgrade to the S type. So I was just thinking about this. 3 years ago, Rose and I bought an EV. And we bought an electric vehicle, and I love it. Greatest car I've ever owned. I don't have a Nazi mobile. We have a different manufacturer, if anybody's. But we're about to roll 50,000 miles on our EV that we've now had for 3 years. And do you know how much maintenance we have had to do on our EV? None.
I don't know.
It's been to the shop twice.
Both for recalls. Nothing that we needed fixed. And this is something that I have heard that car manufacturers and dealerships hate about EVs, that there is no maintenance to be done. I don't have oil to change. I don't have belts to tighten. I got
wait. I have washer fluid to fill.
Yeah.
There is.
It is true.
And
no one could expect you to do that yourself, Rose. That's ridiculous.
Hey, I changed the blinker fluid myself. Thank you.
Blinker fluid?
The joke just goes running past Kathy.
I know.
But now, I'm not saying that this is a conspiracy. I'm just saying that K-type thermocouples, one of the biggest problems is that they decompose. This is the issue with K-type thermocouples. They oxidize. And everybody who's got their own kiln knows when you bought your thermocouple, when you bought your kiln, that thermocouple was shiny and metallic and chrome. And then as soon as you started to fire it, it turned black and green. And that then as you continue to fire, it will spit off little specks of black and green. And then the more that you fire that K-type thermocouple, it is going to begin to flake and fall apart until it literally falls apart, because K-type thermocouples oxidize, and that oxidation is killing that thermocouple. And what that means is that those thermocouples need to be replaced a lot more often. And that might be the reason why the maintenance people don't want K-type or don't want S-type thermocouples, because do you know how many times I have replaced an S-type thermocouple? None.
Never.
None times.
Just the one you broke, though.
Yeah,
well,
the one
look,
Not to bring that up
works.
again. But
I didn't break it. I snapped the casing, and now it dangles.
Which I've talked about before. That is the scare and maybe producer Ben can agree with me, in a studio where multiple people are loading kilns and unloading kilns and busting shelves into the sides. Oh my God. It is a scary thing to make the investment and think about, somebody
Most
busting
S-types. Now, if you've ever seen an S-type, they're tiny. They're literally like 2 pieces of thread, and why they're so expensive is because they're made of platinum and rhodium, like real platinum and rhodium, which are crazy expensive. Whoa. But they are like literal threads of metal. and they come in a casing that is even smaller. And the one that I snapped is actually not our regular kiln ones, because those all have an outer casing which protects that. We have a piece of equipment called a dilatometer, which has one that the thermocouple itself, the casing, not the wires, the casing, it's smaller than a pencil. It's probably half the diameter of a pencil, and you had to pull it in and out the way it worked. And I snapped it doing that. But I snapped the casing. Oh, she's making this is why we don't do a video podcast, you guys, because the judgment in Rose's face radiating at me.
These are the moments I really enjoy. I
don't have much to hold over you, but this one I can like milk till like eternity. So,
run with it, Rose.
Yeah.
Run with it.
I accept my responsibility. I ask for your forgiveness. There's only so much I can do. I am a human.
Anyway, let's get back to the question here.
I know. Let's wrap this up.
But but this is the problem. Most of the ones you'll get for your kiln will actually have an outer casing, which makes them basically the same diameter as the K types. So they're much more stable. So you don't really have to worry about breaking them all that much. They should be fine. But I got to go back. I've said this on the show before, but I need to emphasize this again. Accuracy matters. And man, if I had a nemesis in ceramics, and I know I got all sorts of fights that I pick and things that I think are wrong in ceramics, but the one that really gets me is that I don't think people are concerned enough with accuracy. And I know it's art and you're trying to make something cool. In the studio, they do this. In the studio, they do that. Well, it doesn't make it right, man. If all your friends jumped off a K-type thermocouple, should you jump off one too? But
maybe. I don't know. Depends on what the outcome is.
Depends on how cool that friend is.
Yeah.
Where are we going?
Never mind, I'm doomed. No, but the problem is when those K-types begin to decompose, and I'm talking during the first firing, the way the thermocouple works is that you're passing electricity from one wire to another. And it's that weld point that makes the difference. Well, when you oxidize it, it doesn't conduct electricity anymore. And it is literally failing at the job it is supposed to be doing. It means your kiln is going to continue to be inaccurate. And man, when I was coming up as a student, I was always told, oh, you can't trust a kiln's computer. You can't trust a kiln's computer. And that is 100% wrong. What I learned is that you cannot trust a K-type thermocouple because they're in a constant state of degradation, which is constantly going to change their accuracy, which means your firings are not accurate. So your kiln is going to behave differently in every single firing. And because
your computer is not, it's registering a different temperature, your computer is reading off of that thermocouple. And
correct.
So it's obviously you can't trust it because you're a thermocouple, even though you think it's a computer, it's your thermocouple.
Yeah, it's a constantly moving target. And it is because you're relying, and everybody's kilns now have computers. Like that's just the basic. It's like all the cars, they're all computers now. Everything is computer. But that accuracy, it's only as good as the accuracy it's getting. Okay, because as we talked about before, kilns are really dumb boxes. They are not smart. It's electricity on or off, and then how hot did that electricity make it? If the reading of the electricity is inaccurate, your firing is inaccurate. And that is a huge problem because it's all the stuff that we've talked about. We're not firing to a temperature, we're firing to the completion of a chemical reaction. And that relies on the rate and the temperature. And if those two things are wrong, because your thermocouple is reading different in today's firing than it did from yesterday's firing, and tomorrow's firing is going to be different on top of that, you got nothing. You got nothing. And yes, you pay more for the S-type thermocouple, but my firings are always right. They never change. I change the elements. They don't change because it's always just reading temperature. That's all it's doing. That's its entire job. And I'm sorry, not sorry to everyone who is listening who says you don't need an S-type thermocouple or that K is just fine. You're wrong. And you can fight me when, meet me on the mean streets of New Hampshire, but you're wrong. I'm sorry. You're just wrong.
Watch out. Those sheep are feisty.
I know, right? So let me just, for those that are out there, thinking about their inferior K-type thermocouples like myself, and thinking, okay, I'm going to make the investment. I'm going to S-type. Can you put those in yourself, or do you need somebody to put those in for you?
No, I mean, Matt's done it himself. There is some technical things you need to watch out for. So, I mean, it's basically, S-type thermocouples are a slightly different setup internally in the box, but basically take that out, take out your K-type, put in your S-type. The wiring you have to change. And then you have to go into your computer, and it should be in the manual on how to compensate for the S-type. Or not compensate, but adjust it for the S-type. My question is, though, can you put an S-type in with a K-type? Like, could she change one out at a time?
No.
You
can't.
No.
Because
can you take the other two out and just have one?
Okay, those are two good
Let's
questions.
just keep throwing things at him, Rose. Come on.
First
can
question.
You do
can
it backwards?
I eat a peanut butter sandwich?
Could I be wearing purple?
You're going to have enough time to eat a peanut butter sandwich while I answer these questions, because it's going to take a second. So, number one, you are right. You can absolutely put an S-type into a kiln. That is fine. Now, again, I am speaking as an American. In North America, everybody's using these Bartlett controllers, and they're all designed for that. I cannot speak to other kiln manufacturers, other controllers, but most of the rest of you and the rest of the world already have S-type thermocouples. So you're like, why am I wasting this time? And they just ended the episode because they're like, I don't need to hear this conversation. This is a dumb American thing, because it's a dumb American thing.
Well, where are you going to start with that?
We got a list of dumb American things. But yes, Bartlett controllers, 100%. There's no different controller. You buy one controller from Bartlett. The difference is Rose called it, you have to get S-type wire. You have to replace the wire that goes from the thermocouple to the board. Do not use the existing wire. It doesn't conduct electricity the same way, and it'll change your readings. 2, as Rose said, you just change the settings inside the computer to say, I am now using an S-type, and it will change its input and output for that. And there's another thing you have to do, but RTFM, right? Read the freaking manual. Somebody wrote us recently and said, I don't really like your show because it's too bawdy. To which I said, the title of the show is For Flux Sake. We started that way. Okay. But anyway, I'll watch my language because I know kids listen. Read the manual, everybody. It'll tell you the settings. But the next question that was asked was, can you put multiples? No, because you have to change the settings, and the settings are either K or S. So you can't have both. Can you run with only one thermocouple? No, because if you have multiple, exactly, because if you've got multiple thermocouples, you've got multiple zones. And each thermocouple is controlling a zone. What is a zone? A zone is literally one element wire. So the number of elements you have in there, theoretically, you should have one element per thermocouple. Okay. And so it's adjusting based on where that thermocouple is. And, Supa was saying, oh, it's really expensive to change out 3. It is. But man, another thing when we're talking about kiln design, we need more thermocouples in our kilns. When I talk to our students at Ceramic Materials Workshop, so many of them are suffering because their kilns are hot on the top and cold on the bottom. That is always going to happen because if you've got one thermocouple, it's right in the middle. It's not reading the temperature at the top and at the bottom. It's just reading the middle, and temperatures adjust. When you've got multiple thermocouples in multiple zones, what it's doing is that it's reading the temperature at the top and controlling that element, and reading the temperature at the bottom and controlling that element. And then it says, oh, it's cold on the bottom. I'm going to fire the bottom element more to produce more heat down there, but the top is already hot, so I don't need more heat up there. And it's balancing that heat. And so, yeah, you do need all of them to be at the same level of accuracy, and you do need all the thermocouples.
Today's episode is brought to you by the Rosenfield collection of functional ceramic art The collection exists as an online source for research and inspiration, featuring photos of thousands of objects made by over 800 artists. The images are high quality and can be used with no permission required. To find out more, visit www.rosenfieldcollection.com.
Glazes don't make sense, but that's why Rose and I are here at ceramicmaterialsworkshop.com, helping translate glazes for real ceramicists like you. So join us for our brand new class starting October 1st. For everyone from beginners to masters, we clear up all the mysteries of glazes to make them work for you. Join us at ceramicmaterialsworkshop.com for making glazes make sense.
Well, let's kind of switch gears, shall we? Enough thermocouple talk for a bit. We're going to talk about shelves. And Jessica has a great question. I'm going to have to read it, though. But Jessica asks, my question is about kiln shelf stacking and warping. I have a 27-inch wide by 27 deep kiln, and my cordierite half shelves keep warping so badly. I have run through almost 2 full sets of shelves that are now unusable. Wow. I understand that not all shelves are made the same. So last time I made sure to buy the pressed shelves instead of the poured ones, but it's still happening. I'm a production potter and run my kiln back to back. My kiln furniture is positioned in a triangle, so don't start talking about that. I don't know what to do to stop this warping from happening without having to buy advancers, and those are expensive. So any advice would be extremely helpful. This is interesting. Wow, we've all dealt with this, but that's a lot of warping.
Well, I want to know from both you, Kathy, and from producer Ben, because you guys have worked in a lot more studios than Rose and I. We've always sort of, since we left college, been in our own studios or the businesses that we work at. But do you guys see this a lot? Is this common?
Yeah, so I'll take it first. So if you can flip them, we try and flip them. We do flip our soda kiln shelves to try and avoid warping. They warp very badly. But with the electric kiln shelves, they just, you just hope for the best, but I don't see that much warping like what she's describing. So, and I also don't know the difference between the poured and the pressed. I will say though, I just spent about close to $10,000 buying advancer shelves. So I did make the investment this year for both our electric kiln and gas kilns. Yeah.
Those 2 shelves are going to suit you really well. I think you'll really get a lot of life out of those 2 shelves.
Those 2 shelves. It was slightly more than that, but I will say it's a bummer when you find out, yep, if you drop those on the floor, they're going to break in half.
Yeah.
We actually have never broken an advancer shelf, I have to say. So they have some.
No, just thermocouples.
As Rose brought it. Yes.
Well, in my studio, we hear equal shelf breakers. We have broken all the normal ones and the advancers, and any shelf we've gotten, we've accidentally broken.
Impressive.
Because we're really precise with our movements. But yeah, I think the key might be that they're getting too thin of shelves, which I know might sound obvious, but the thickest shelf you can pick up comfortably with your back is what I would recommend. Because I've noticed the ones that are, and this is cordierite, but the ones that are, I wish I knew the measurements, but the ones that are slightly thinner do warp more. So the thicker ones I've noticed have not been warping. But I also, kind of on a related tangent, one of my friends told me maybe a year ago, that they were running into bad shelves. And once they started saying that, as in the manufacturer was manufacturing a bad shelf, like that they were having problems with their dry materials, then I started realizing all of our shelves were also cracking is what we were having. But like 6 or 7 of them would crack, brand new shelves in exactly the same spot, which the question I have
the
been,
spot?
The basically long way of a hexagonal shelf. No, they're 5-sided.
All the way across? Would break?
Yep.
Whoa.
Crack in exactly the same spot every time.
Scary.
Like straight down the middle, or
But have y'all heard anything about this? The idea of like bad refractory, bad dry materials hurting shelf manufacturing?
well, I mean, we have to talk about cordierite, which
Yeah.
is the real conversation. So for people who don't know, cordierite is what most of the tan shelves in your life are made of. And cordierite is a material that is a magnesium aluminosilicate. And cordierite is theoretically pretty high temperature. It should have an easy working range between 1100 and 1300, which is sort of cone 2 to cone 10. Easy. It should be able to do that. And it should go up to 1400 plus. The problem that I would have to guess is cordierite's composition is basically 10% kaolin or ball clay or whatever they're making it with, and 90% talc.
Mm-hmm.
And in North America, we are in a talc crisis. We have major talc issues. But of course, this goes to one of my favorite things that Rose ever had to experience with her old manufacturer and cordierite.
Yeah. So I worked for a large tile manufacturer, and they had we produced through body mosaic tile. So no glaze on it. And it was just the clay pressed and put into setters. And those setters were made by the same company that I worked for, but a different manufacturing arm. So we would order our cordierite setters from our company to them to produce and to ship to us. Well, at one point, the big green egg showed up, the smoker that you see in a lot of people's backyards. Well, that company made our setters too. Only the big green egg was much more lucrative and demanded more production time than our setters did. So we competed with the big green egg to get production time to make our setters so we could make tile at our factory, at our own company to make tile. So it's interesting. And
that's fascinating. Huh?
And what we understand is that here in the States, our previous talc source, which went by a lot of names, some people call it Texas talc or Am talc or Pioneer talc. What we have been told, although we haven't been able to get confirmation from Rose's former coworkers, is that her old company bought that deposit of talc. And this is why we lost that talc source, because they bought out the mine because cordierite, which is the big green egg, is cordierite.
It's all
and the
cordierite.
shells are, it's all cordierite. And that's 90% talc. And so they could not get enough talc until they just bought the talc mine to make the big green egg. And which is why we lost the last good source of talc. And the crisis we've had with, this is not Materials Corner, but welcome to Materials Corner, is that we have been suffering with talc substitutes. And there are 3 talc substitutes that are out there. One's called Fabi talc, one's called Sim talc or Simbar talc, and one's called Silverline talc. And they're all bad. I have yet to find one.
They're just not great for our applications.
I can't get them to even work in glazes.
Yeah.
Like they just do not work. And it is a huge problem. And I would have to suspect if those kiln shelves are being made, they have now had to source an alternative form of talc because the one that we had is gone.
Yeah.
Wow.
And is that talc performing? What I can say about those 3 substitute talcs is that they have got 20% more silica in them by default. But even when I try to put them into glazes and have them work, they don't even melt. Like they don't act like talc. And I don't know why, because I mean, you should be able to compensate for that chemistry, but they just don't work. And I suspect, again, this is pure speculation, that what may be going on is that we're now having quality control problems because of this talc change.
Wow. It's amazing though that more people aren't shouting to the rooftops having problems like Ben's studio.
Yeah. I mean, I imagine it's out there. It's just not, it's a broken kiln shelf. Let's keep moving.
Interestingly enough, the kiln manufacturer who sold us to us sent us brand new shelves for free. So they admitted first time ever. See, Matt almost died.
So they're hearing about it. I gotcha. Okay.
Yeah.
Yeah, that means something. I spit my tea out all over the microphone. Ben got me.
Wow.
And I actually don't even blame them. It is a shortcoming that if this is the reason, I don't know that this is the reason that they might be bad at making shells. You know, there was the question about the poured versus pressed. Like poured is like literally slip cast, and then pressed is like a dry press or a ram press style. Because the interesting thing about cordierite, we get this question all the time at Ceramic Materials Workshop where people are like, hey, can I make my own kiln shells or my own kiln posts? And the answer is absolutely not. Because cordierite is unplastic. You have to form it in some sort of a mechanical way because it's 10% kaolin. To put that into context, to make a clay body at the minimum kaolin content that is hand formable, you need 50% kaolin. So at 10%, yeah, the machines can press it, or you can make it into a slip and cast it, but you can't press it. But yeah, I don't know why they're having the problems, but there is that. I will go back to the original question of saying like the warping. I have seen that before. I would also say that that's a bad composition of cordierite, that why they're doing that or selling it, I don't know. But cordierite should be relatively high temperature. And the reason why we use cordierite is because it's got very low thermal expansion. That's why they use in the Big Green Egg, which doesn't expand very much when you heat it and cool it, which is why it can be used for a kiln shelf. But I definitely have seen kiln companies being more innovative with building geometry into their kiln shells. I would think that would help. I've never used those shells myself, but I've seen that out there and going, oh, that might solve the problem. But it also means why, there's a comment about them being thicker or thinner. The thicker that is, the more resistance it's going to have to bending and warping, because it is holding up a lot of weight. And if the chemistry is not great and it's softening and warping, that absolutely will happen.
We also have the hollow core shelves, which take up more, and maybe for a production potter this doesn't make sense, but it takes up, what are they, like an inch thick, I think. So it takes up more kiln space, but we do see very little warping with those for our electric kilns.
I would think thicker is definitely better. And if they're just use geometry to make them thicker but also way less, fine, that's a win.
Mm-hmm, mm-hmm.
Yeah.
Wow. That is bananas. Now I got to be suspicious of the kiln shelves and
Well, our materials are changing all the time. Loss of manufacturing in the U.S. is not just jobs. It's a lot of raw materials too. I know. Sad.
Well, now that everybody's all depressed.
Well, let's end on that note then. Oh my goodness. No, we will come together next time, I'm sure, with much more positive things to say about materials everywhere. Don't you think? No, nobody. All right. Well, we're going to come together next time anyway. So Matt and Rose, till I see you next time.
We'll see you later, Kathy.
Well, folks, that's it for this week's episode of For Flux Sake. I'd like to thank the listeners who submitted questions this week. And if you want your question answered on the show, shoot us an email at forfluxsakepodcast@gmail.com. So join us next time. And when in your studio, remember what Rose always says.
Always remember to test, test, test. This is a test of the emergency glaze system. Beep.
Hi, everyone. If you've been leaning into our glaze deep dives to troubleshoot your studio struggles or just geek out over oxide ratios, we'd love to invite you to join us over on our Patreon.
Think of it as the flux that helps our creative process flow a little more smoothly.
Producing for Flux Sake takes a lot of behind-the-scenes chemistry, from research time to tech costs. By becoming a Patreon member, you're directly helping us keep the show independent and technical.
By supporting us at the $5 a month tier, you get access to our Patreon Flux U bonus episodes, archived for Flux Sake Season 1 and Season 2. And you get priority submission for your questions from the team to answer in future episodes. Oh, and along with exclusive for Flux Sake merch.
We know how quickly the cost of cobalt adds up, so we've kept our tiers accessible. Every bit of support means we can spend more time answering your questions and less time worrying about the business side of things.
So check out our link on our show notes or visit patreon.com and keep the conversation and the kilns firing.